So back to coverage metrics. So we just talked about statement coverage, which is closely related to line coverage, but it's a bit more fine-grained. And now let's talk about what is probably the only other test coverage metric that will matter in your day-to-day life unless you go build avionics software. So branch coverage is a metric where a branch in the code is covered if it executes both ways. So for example, to get 100% branch coverage for the statement that tests whether x is 0, it would need to be executed in a state where x was 0 and also in a state where x was not equal to 0. And so in many cases, branch coverage and statement coverage have the same effect. For example, if our code only contained if-then-else loops, the metrics would be equivalent. On the other hand, for code like this that's missing the else branches, they're not quite equivalent. So we can take as inputs to this code x equals to 0 and y is minus 1. These inputs were sufficient to get 100% statement coverage. On the other hand, these are not sufficient to get 100% branch coverage. So what happens is these cause the taken branch of the if to be executed, but not the else branch, and then the taken branch of the second if to be executed, but not the else branch. So there are different ways to score branch coverage, but one way we can do it is there are two ways to take this branch, two ways to take this branch, so we could say this is 50% branch coverage. The other thing we could do, however, is do what our Python module for counting coverage is going to do. We could say that both of these branches were partially executed. That is to say, one of their possibilities was realized during testing. No branches were completely missed, and no branches were totally covered. And so let's go ahead and see how our coverage module tells us this. All right, so as you see here, I've typed into an editor window the same code that I wrote down by hand on the left part of the slide. And so we're going to invoke the function foo with x being 0 and y being minus 1, and let's see what happens. So we're going to run this under the coverage tool, but this time we're going to give the coverage run command an argument -- branch. And that simply tells it to measure branch coverage instead of just measuring statement coverage. So it's again going to render some HTML as the result. And if we look at the output, it's going to tell us that out of 6 statements, all 6 of them were run, and there were 0 missing statements. So at the statement level, we've achieved 100% coverage. On the other hand, at the branch level, we had 2 branches that were partially executed. That is to say, only one of their 2 possibilities was realized during execution. So now if we change this a little bit by calling foo a second time with 0 and minus 2, run the coverage tool again, what we'll see is that the second branch, the test of y, now is executed both ways. On the other hand, the first branch, the one that tests x, still is partially executed.